Here we have a limit question with the square root. Let's see what's the technique for solving such a thing. But before we do that, anytime you have a limit, you want to see if plugging in the value gives you a finite value. If it does, then you can happily write that as your answer. So if you plug in 3 on top, 6 minus 2 times 3, that's 6 minus 6, which is 0. If you plug in 3 on the bottom, you get square root of 5 times 3 plus 1 minus 4. 5 times 3 is 15. 15 plus 1 is 16. And square root of 16 is 4. So that becomes 4 minus 4, which is 0. So it's 0 over 0. Well, what is 0 over 0? This is what we call indeterminate. Meaning that unless you investigate further, you won't be able to find the value of the limit. So don't write 0 over 0 and say that's equal to 0 or that's equals to infinity or whatever. Whenever you have 0 over 0, that means you achieved nothing. Okay? 0 over 0 doesn't tell us anything. Okay, so let's go back and see what we can do. So what is the trick for dealing with such a limit? The trick is to multiply what we call the conjugate of the one that has the square root. So here's the part with the square root. It could be square root minus a number or other thing without a square root. You might have something minus a square root, or even you might even have a square root minus square root. In any case, you take that sign between the two things and change that sign. So it's minus, now we're going to make it as plus, and that is what we call the conjugate of this denominator. And the conjugate of this is this, and we want to multiply that top and bottom. Now this does not change the original function, because in a fraction you can multiply anything top and bottom and it does not change the value of the fraction. So for example, if you have 2/3, multiplying by 5 top and bottom will give you 10 over 15, but 10 over 15 is exactly the same as 2/3, right? So it did not change the value of the fraction. And that's a property of a fraction. You're allowed to multiply top and bottom anything as long as you're multiplying the same thing top and bottom. Okay, so let's continue on. Let's see what we have. Now the core formula that we're using anytime you multiply the conjugate is the following. A minus b times a plus b is equal to a squared minus b squared. This is also known as the dots formula, which is an acronym for difference of two squares. Okay, the difference of two squares applied to here makes the denominator become 5x plus 1 squared minus 4 squared. And now you see why you would want to multiply the conjugate. That's because when you square a square root, they cancel. So that's beautiful, right? On the other hand, the top one, you don't want to multiply. If you multiply this, it only gets more complicated and confusing. You just want to leave it like that, okay? And let's use that property to cancel 2 and these 2, and then you get limit x going to 3 of 5x plus 1. 4 squared is 16, so minus 16. And you have 6 minus 2x times square root of 5x plus 1 plus 4. Okay, now let's try to see what we have here. This one down here, this becomes 5x minus 15. And you should make it as a habit to factor as much as possible. If you see something like this and you see that 5 and 15 are common, they have a common divisor 5, then you should factor the 5 out, and then you get x minus 3. That makes things a lot easier to calculate. Okay, let's continue to write down what we have so far. So here's what we have. We have 6 minus 2x times square root of 5x plus 1 plus 4 divided by 5 times x minus 3. Limit x going to 3. Okay. Now when you plug in 3 on here, so if you multiply 3 to 5 plus 1 and take the square root and add 4, that gives you square root of 16, which is 4. 4 plus 4, that's 8. Okay, so this part will become 8. But these two, when you plug in 3, it gives you 0. When you plug in 3, it gives you 0. So although we worked so hard by multiplying the conjugate top and bottom, we still have 0 over 0 type indeterminate. Okay, that's not good. So what do we do? Well, then here is a nice fact from pre-calculus that says if you have a polynomial, 6 minus 2x is a polynomial, right? If you have a polynomial, in my mind I'm thinking of 6 minus 2x as this px, and if p of 3 is 0, which is the case, right? If you plug in 3, it's 0. Then it's true that you can rewrite p of x as x minus that number times another, I don't know what, okay? And this is what we call the factor theorem. If you forgot your pre-calculus, go back and review this factor theorem. And it saves us because, see, I know that x minus 3 is in the bottom. So if there's x minus 3 on the top, then I can cancel them, right? So how do I do that? Well, try to see x minus 3 times what gives you 6 minus 2x. Well, to create negative 2x, I better be multiplying by negative 2, right? So maybe it's negative 2. Let's see. Negative 2 times x gives you negative 2x. Negative 2 times negative 3 gives you 6. So perfect. This is same thing as 6 minus 2x, okay? So check that these two are the same thing. You still have square root of 5x plus 1 plus 4 over 5 times x minus 3. Limit x going to 3. And this hard work now pays off because now we can cancel this with that. And when you plug in 3, you get, we already know that this will give you 8. That's going to be 8. And there will be negative 2, and there will be 5. So the answer will be negative 16 over 5.